All right, we are back. CH9 Live. Tweet questions to this thing. You're a Twitter user, you know what it means. We are continuing with C# and VB. We have three very special guests, Alex Turner, Maz Torgerson, Lisa Feigenbaum. Thanks for coming on.
Thanks.
So we just had Anders. So we talked a lot about async and C# in general. But you guys are like sort of the team behind the async stuff specifically. And of course, Lisa runs the whole managed languages stuff. So let's start with, a little reflection on async and Windows 8.
Yeah, so really sort of core about a year ago, we were talking about Windows 8 and figuring out how that, how C# and VB fit into that and what it means. And we realized pretty early on that some of the async stuff we wanted to do really meshed really well with the async stuff that was going on inside Windows runtime.
Okay.
You think about the multiple platforms, Anders touched on that, about how they have to support JavaScript. And in the JavaScript environment, really things have to be async. You're stuck on that UI thread where you have to do your network requests and things like that. And you need to have async support deep in the language and deep in the API, at least. And so we, on our side, are saying, well, we want to do async language support anyway to help that out. And so how can we make sure that these WinRT APIs that we're consuming are actually going to be able to be consumed naturally as the task returning APIs that you'd want?
Yeah.
And so we were able to work pretty closely early on to make sure that that the futures support that they have that actually returns these iasync operation of T objects meshes really nicely with task of T. And we have that direct ability for you to await the async future objects you get back from Windows Runtime APIs.
Excellent. And so this sort of makes it easy for the managed async stuff to interoperate with, say, JavaScript, because they have the same problem of also having to map into the Windows Runtime async model. Right?
But, so one thing that you can say is lucky or a sign of the times or whatever is that even though C# VB on one side, Windows Runtime and JavaScript all have their own async models, they're actually very closely related. They're sort of like they're future-based, we call it. Like there's this notion of a first-class object that represents an ongoing activity that you can then communicate with and sign up callbacks to. And they all have that at their core, which is lucky for us because that's what enables us to mesh these things together. But I think there's really a general realization that you need this kind of modern first-class abstraction in order to deal with asynchrony in a general way. So we kind of all independently got to that idea, and that just sort of worked out really nicely.
Excellent. So Lisa, I mean, in some sense, VB that we don't talk about enough, but it is a managed language that has the same level of support, right?
Yeah, absolutely. So here at the conference, we've been talking about Metro-style apps written in C# and Visual Basic. We've been talking about the async feature coming in C#5 and VB11. So lots of great innovation happening in both languages.
And so the question I would have is the way that JavaScript approached the problem is that using promises.
Right.
And we've had this conversation when you first announced this async thing. Why aren't they just promises? Why didn't you use the async? I should have asked Anders this, but he gets off the hook. But just curious, like why the async await and not promises? And that's just my question that I just pulled out.
Actually, it sort of is promises. There's a task type in .NET, which is our future type.
Yes.
And you can totally use that like promises. Instead of saying .when, or .then, I think, you say .continue with.
Yes.
And it's just a different name for the same method, really.
Okay.
So the whole chaining together, you can totally do that in an API-based fashion. Actually, you can do that today in C# 4.0 and .NET 4 because the task type is already there. So what the await stuff does is just add an additional layer on top of those kinds of abstractions that lets you get out of signing up the callbacks manually with such a method and just write your method in a linear fashion, the way that you're used to, describing things in the order they're supposed to happen.
And you can think of it also in a similar way to link, right? You have like the .where, .select kind of raw API pattern, and there was a while where we were actually thinking of just shipping that and calling that link. And we realized that for a lot of scenarios when you have like multiple from clauses, you're doing what would turn into a select many, that what you want to write starts to get further and further away from what you would do to do it like manually.
Okay.
And so like when Anders showed it, if you have just a method with one await in it, you could imagine having the first half and then saying like task.continue with and doing the second half. And maybe you just do that yourself. But once you have a while loop and then you have try blocks and stuff, you start to diverge from what's easy to do today, and then you really want the language support. And it's sort of, we had this realization that you can pull it off and you can have a great experience with tasks, which you can do today in .NET 4.0, but then there's this further step that you can go to really push the language forward and make it easy.
Yeah, and that's one of the great aspects at Microsoft, being able to control all aspects of that stack that we can really enable a great experience across them.
Awesome. So remember to tweet questions to hashtag CH9Live. I mean, this should be kind of obvious by now. Please tweet questions. I mean, come on.
And that's on
This
Twitter.
is a question that we've already answered, but we're going to talk about it again because apparently there's confusion out there that Metro apps somehow don't need to have a runtime if a language is a runtime required language like C#.
Yeah.
You need the CLR.
Yeah.
So yes, the CLR runs. Can
Right,
you answer
so
the question?
when your Metro style app in C# or VB runs, then we load the CLR 4.5, just like you're familiar with from .NET Framework 4.5. So
Sure.
absolutely, it's there.
Right, because there's not a garbage collector. I mean, the Windows runtime is ref counted for the new COM, right? But there's no garbage collector and all the other great stuff you have with type, verification, blah, blah, blah.
Like we think of the Windows runtime more of like, you think of like the C runtime in terms of libraries that you're targeting. Like it's not a runtime in the sense that we think of the .NET Framework and the COR as a runtime, as like a replacement for the COR. You're still in a managed language, you're still using the COR. It's a set of APIs that you can talk to, and in this case, talk to and consume far more directly than a lot of the COM interop kind of stuff you do today.
Absolutely. Gone are the days where P invoke and no PIA in the Metro world.
Yes.
Rock and roll. We have a VB question. Where's the VB alert? Where do you see the future of VB?
Sure. So, today Anders Hallsberg was talking about the future direction of C# and Visual Basic. So really that talk was outlining our future directions, as you can tell from the title. And, here at the event, we're talking a lot about what's coming in VS11, the next version of Visual Studio. And so there we have async and also the WinRT support. And then looking further beyond that, we have a project Roslyn that will be sometime after Visual Studio 11. We're actually going to have a CTP of that release next month.
Okay.
So that would be the further future direction of where this is going. And in that case, we're actually rewriting the VB compiler in Visual Basic. And we're actually exposing a lot of these APIs that previously you could only access from the compiler. And so I actually started on the team as a IDE PM. And I remember there was a lot of replication that we had to do when we'd add a new language feature. We'd have to implement it in the compiler, we'd have to implement it in the IDE, and by exposing these APIs, now it's going to make it a lot easier for us just to do that once in the compiler, and then for our IDE team, and then also third parties to be able to take advantage of that.
Yeah,
Awesome.
it should really help with this pace of language innovation too, right? Because we're talking about, like, again, talking about different languages and different places where you have to put things. We kind of joke that you have to implement features that we do for this release like 12 times, right? Like you have to do it once in VB and C#, and then you have to do it in the compilers, and for each language you have to do it in the IDE, and then in the expression evaluator for when you're debugging, and then you also have to do it in the runtimes in case you're doing late binding. And then we also have to do it, in Roslyn to keep all that stuff in sync. And so it'll be great when we actually have this, not unified code base, but the ability to have a lot of chunks that we can actually share in terms of common logic, and then build these features from a much more unified place.
Excellent. And we talked about the coevolution, I guess, a year ago or 2 years ago. So sticking with VB, and this looks like an angry VB person, and that's okay. Why do you still push all the new features to VB? That should be just basic without classes and link and async.
So actually, I'm a community program manager now, so I work a lot with our communities. And when we look at our customer bases, the kinds of things that our VB developers are asking for and our C# developers are very similar. So both want to write great asynchronous apps that are responsive today, and so that's why we continue to bring these features to both. So previously, we had considered a different strategy where we were differentiating. And really all that led to was dissat, because we would add one feature here and then one feature there, and then this guy wanted that one and this one wanted this. And so then that was where in the 2010 release we finally came to a realization that we really wanted to embark on this coevolution strategy. And so since then we've been adding all of our new major language features to both, and we've also been evening out where there were a few major gaps. So for example, in VB11, VB is getting iterators, which were a hole that were not there previously, that was existing in C#. So we've really done this in response to our users, and we see pretty large user bases on both sides, so we're trying to provide that to both.
Excellent.
And one interesting thing there is, if you look at some of the stuff that's going on in Roslyn, you get like the C# interactive window and the VB interactive window, things like that, then you're starting to get not to a different language, but you think of sort of a scripting dialect of the languages that we have. And in there, if you watch Anders talk, you can see he's just able to write like 1 + 1 and hit enter. And he's not even in a class, he's not even in a method. And he's evaluating things. So some of the scenarios that VB traditionally, if you go back and you think of like VBA and some of the different places where the Visual Basic language would be used back in the VB6 days, when you get back to an interactive window, you can imagine environments where people can pull together stuff where you aren't really thinking about classes if you're at a much more local level.
Sure.
And hosting inside environments being replacement for scripting languages and that kind of stuff, you can start to imagine getting back to that kind of environment for when you're targeting that domain.
And so one of the questions I would ask is, before we get to this one, because that's going to be a very quick question, maybe we'll get this one first, because you are why we're doing this. So is it C# 4.5 or C# 5.0?
So it is C# 5.0. We've kind of lucked out in the past that we happened to just about align with the framework versions as the framework was iterating. But this time, there's at least a 5 in the name of the framework that we're part of.
So is it VB5 as well?
No, that's already been a VB5.
Oh, so what is it now?
We're at VB11.
VB11.
Yeah.
Right on.
It's getting old.
That's like C++ 11. All right. So the question I want to ask is, in terms of the coevolution and the Roslyn project, why is it necessary to implement the VB compiler in VB? Why couldn't you implement it in C#? Why not just have one compiler?
Well, we totally could. We still need 2 compilers because the languages are different.
Of course, and there
are actually a lot of shared parts.
Okay.
Shared parts are written mostly in C# as it happens, but the core of the 2 languages are written in themselves, and that's actually a very old tradition of compilers that you write them in the language they compile. It's really good exercise to do the first dogfooding of your own language that way, to be able to bootstrap there. And we deviated from that shamefully for more than 10 years by having both implemented in C++, which is a great language to implement compilers in, but it doesn't give you any of the immediate feedback. Now they're very full-featured languages that are excellent for writing compilers, and we should take our own dog food.
Yeah, and even within Microsoft, it's been great even to just have this very large, sizable VB code base to bang away at as we're even developing the VS11 stuff. And we want to ensure that what we work on actually behaves properly. If they use async, they use things like that. Like we can vet these features in a real code base early, and doing it in C# and VB has been super valuable for us.
Excellent, man. So Nico159 asks, what about unit testing with the new async programming style?
Ooh, that's a nice and difficult question, actually.
Great.
So the thing, unit testing frameworks, almost more than anything else, tend to rely heavily on synchronous behavior. So the way you typically have a unit testing framework is that you blaze through your tests one at a time, and when they return, you go on to the next one. Now, asynchronous methods return before they're done, and so they haven't had their full effect by the time they return to the framework. And so unit testing them with traditional unit testing frameworks is not so easy. You have to do something to make sure you actually don't kick off the next test until you've done the previous one, and you don't check the success or failure before it's actually done. So that's a bit of a challenge. There are certain, like in the async CTP we sent out 9 months ago and refreshed in the spring, there's a sample that sort of experiments with showing some of the ways you can do this. The thing is, it gets a little technical, but
that's fine. We have a developer audience.
Exactly. So you kind of want to execute these asynchronous methods in the right kind of context, the right kind of synchronization context, so you can know through that context when things complete.
Okay.
And at the end of the day, I think unit testing frameworks will just have to grow up and embrace the fact that tests will be async.
Well, I mean, that actually brings up an excellent point, right? Because Windows runtime is very asynchronous. And even though you guys have done beautiful work in the way that you've made your async model sort of look sequential. So as a developer, I'm just writing lines of code, and I don't have to bang my head against the wall and deal with callbacks and all that crap. However, I do need to understand some of the outlying areas of asynchronous programming.
And it's important to remember the point of async is that we keep your code looking the same, having the same structure, but there are these little things you change, right? So you make it return task, and then at the point when you're calling it, you'll await it if you care about waiting for completion. And so you think if I'm writing my unit test method, that the test runner is calling a void method today, you could imagine it calling a task returning method and then deciding to await it to actually know when that thing completes or when it has an exception, rather than having the exception come back on a callback and blow up the test runner rather than actually just give the test runner a failure.
Yeah.
And so, as Mads is saying, you could imagine then moving forward you have test runners that actually understand async and allow you to have not just void returning but task returning methods, or have them actually use custom synchronization contexts that understand how to know when the operation completes and doesn't.
Well,
it's a general thing, though, that asynchronous programming has more complexities to it than synchronous programming.
Yeah.
One thing is making it easier to write it, and that's what we're doing. That's the only thing we're really doing with the language features, is making it super smooth to write async. And on the other side, so we're making it easy for you, and on the other side, we're also pushing you to do it by giving you async-only APIs in Windows Runtime and other places. So async, though, at the core still has new challenges that you don't have with synchronous code, and you have to deal with those. If you think about asynchronous code running on the UI thread, for instance, now it has, so it will have holes in it. Like previously you would have one chunk executing, then a callback coming back later and getting executed and so on. It would kind of be evident from the code that sort of discontinuous separate chunks of code were being pumped to the UI thread at different points in time. Now that's sort of a little more implicit. Every await is really a hole in your code where other stuff can happen on the same thread. And so it's kind of like collaborative scheduling in a way. And it's much nicer to express, but you still have to deal with the fact that other things can happen in between. The global state of the world can have changed. Indeed, that's the purpose, right? You want to be able for people to muck with the UI at the same time as your asynchronous method is awaiting.
Absolutely.
So if you're relying on global state, you have to check after every await, in principle, that global state is still valid if you think somebody might have changed it. That's sort of some of the complexities of concurrent programming starting to knock on your door a little bit. You don't have the sort of preemptive scheduling issues where the world can change at any instant. You have well-defined places. That's why it's collaborative scheduling. You have well-defined places. Every await, that's where the world can change.
Okay.
But you still need to be aware of that. And you didn't before. You were just synchronous and you're just blocking the UIs, and nobody would even press a button because you made them not do it.
Absolutely.
So you just have to deal with that.
Perfect. Well, and the developers are going to have to experiment and learn and get used to the pattern.
Yeah.
Because it's all async. Jordan Terrell asks, have the iterator and async state machine generators been combined?
So in VB, where we have, VB is where we actually now have iterators for the first time.
Nice.
And so, like, if you know much about how this works, like iterators and async are both using state machines under the covers.
Okay.
And so we were able to use the same logic in VB across both sides, and that's why we were able to get iterators. We were able to get iterator lambdas because we needed async lambdas, and it's really the same infrastructure there. When you look at C#, we actually, I believe in the async CTP, it was actually the same, and we ended up using the same implementation. I think now we've actually separated it back out. It's one of these things where it can be more work to actually go back and figure out how to get all the compatibility with the quirks of the existing implementation versus even just keeping it and doing a new thing that's separate. And so Roslyn already has this issue. Roslyn, as an extended project, is having to figure out how to maintain compatibility with all the different contours of the language, of both languages. And so that's really the right time for us to go figure out how to have a common implementation that underlies iterators and async across both languages.
But since it was a CTP, you should be able to break something.
No, so not compatibility from the CTP,
okay,
but for iterators, which already exist as a language feature.
Understood.
Yeah.
Understood.
And
All right,
it's a very fair question. Actually, it's been very useful sometimes when explaining how we implemented async in C# to kind of refer back to the example of how we did it for iterators and some useful context.
Absolutely.
One of the things you got to realize with iterators is that a large part of link to objects, is actually implemented with iterators in C# in the .NET framework. So we rely heavily not just on that feature working exactly the way it's used to, but also on certain efficiency expectations. And until we can satisfy ourselves that a new implementation would fulfill all those existing expectations, we're not going to move over. Even though it doesn't seem rational to have two implementations of the same general pattern, we're going to stay with that until we're certain that the new one is as reliable and totally compatible and as performant as the old.
Excellent. So we have a question from God Saucy, or I think that's your name. If unit tests are not suitable, how do you test async?
Yeah, I think that's really like what we were saying, where
yes,
like you're going to have to either have unit test frameworks that ultimately support it, at which point unit tests are suitable.
Yeah.
I think unit tests as a concept are definitely suitable, but it's just the peculiarities of the particular frameworks we have today.
Sure.
And then there are workarounds. So the workarounds are basically that you set up a custom synchronization context, or that you kick something off on a background thread and then block the thread that the test runner started you on, so that by the time it completes on that thread, you've actually awaited the operation and come back. And you have to figure out different tricks like that, and there's gotchas around there. So I would check out the sample that we have in the CTP.
Cool. I want to stress, it's definitely not that unit testing and async are not made for each other.
Yes.
They're totally made for each other.
Okay.
There's no conflict in the principles of those two. It's just that current unit testing frameworks assume synchronicity, and they don't get that.
But see, that's sort of what we were talking about earlier. We, as developers, we all still assume synchronicity, or synchronous reality of the universe. In fact, in the new Windows, in the Metro world, that's not the case.
Right.
Just as we know in web programming, that's never been the case. So leading into this question, any plans to make async server-side programming and web apps easier, safer? I don't know why it's necessarily unsafe, but you can address that question.
So, I mean, I can address it in terms of the easier side, not necessarily the safer side.
Okay.
But
he gets to do that. Or we'll put that on Lisa.
Go for it.
No, go for it.
But in terms of being easier, there's a lot of excitement now around you get web frameworks, we talk about Node.js and things where you're having the framework itself be async at its core, and you're really just dealing with blips coming in, and you get a packet, you deal with it, you send packets out, and you're not thinking about spinning up threads. You can get massive, higher scalability. People were talking about that. I forget who it was, but in the keynotes, the big picture sessions, we were talking about the kind of stuff moving forward with ASP.NET MVC and having the async controllers and stuff, where it's really the same idea, that you have something which isn't going to try to spin up a new thread for each request coming in and then block the thread and run the server out of resources and require too much scaling for a low number of users, that you actually get to have of async. I guess not necessarily making it easier, but just letting you get a huge amount of scalability for doing basically the same implementation.
Excellent. Now, I don't necessarily understand the safety question. I mean, what's unsafe about async on the server?
I don't know either.
Okay, so let's move on to this next one. Why didn't you ask Anders this, man? But why is there a go-to keyword in C#? There's a go-to keyword in C#? It's just as an ugly way to program with it. There's always an alternative. There's a go-to keyword in C#.
Yeah.
Okay, I've never used it. So why is it there?
That's a good question. I think it was one of those, hey, we know how to do it. It's a relatively clean go-to that doesn't let you jump into other scopes, stuff like that. Actually, in VB, it lets you do even that. But I agree that go-to is not something you would normally use in a general go-to is not something you would normally use in normal code. There's a restricted version of go-to that you use to jump from case to case in switch statements, but that's kind of like a different operator. Sometimes when you're auto-generating code, it's really useful. Like you want to write a state machine, or hopefully you're auto-generating a state machine and not writing it yourself. But even if you're writing it yourself, that's very hard to do without a go-to.
Okay.
That's just a low-level thing you have to express with things jumping back and forth.
The iterator, the async state machines basically make use of that, like
exactly.
under the covers. They'll emit IL directly, but if you were to do something like that as a code generator yourself, you'd want it. One other thing I'll throw out there is we actually have one of the samples. It's the paddle game sample. It doesn't use goto, but it shows how you can represent sort of just a general purpose state machine, like a game logic state machine as async, where you're looping around and you're looping while you're going through the rendering phase, and you go back to the menu and you go around, and that's a very simple game loop, and so you're able to just do it with while loops and stuff. But you could imagine a more complicated state machine where you want to jump between different states, and you could imagine representing that with an async method so that your state machine could pause and such, and then using goto there to jump when you want to transition between states. So it's one of those things where you really want to be judicious and not just throw it in everywhere, but you could imagine those little cases where it's
great that you have it.
I will say to the person who asked the question, you are free not to use it.
You are free not to use it. I'm sure you guys use it in your compiler implementation.
Oh, yes.
Oh, yes. All right, so async methods, this is from Jordan Terrell. Async methods must return void or a task. Did the languages take a hard dependency on those types, or is pattern matching involved?
Yes, so in terms of what they produce, yes, we did take a hard dependency on those types. When you consume, when you await other asynchronous things, that's a pattern-based approach, so you can await things. It doesn't have to be a task. It can be the Windows runtime, async operations, or stuff you cook up yourself. But in terms of production, we've chosen to marry ourselves to the task types for a couple of reasons. One of them, I think the most prevalent of them being that you get a much better type inference, much better overload resolution when you can always assume that a task comes back from an asynchronous method.
Okay.
Especially for lambdas.
For lambdas, that turned out to be very important. We tried actually first with a pattern-based approach, and then we realized, A, it got really awkward sometimes, and B, we didn't really need it because you can build all the other ones by thinly wrapping either the task itself that comes out or a task returning delegate around the function that returns the task. And so, for instance, in Anders' talk, we show the bridging methods from task-based APIs back to the Windows async results, and they're totally that. They're thin bridging methods that just wrap tasks in something else.
Cool. So Lisa, you work very closely with the community and developers who actually use all of this stuff. What's the assessment? I mean, are people stoked with the async await pattern? Are you getting good feedback? Have they found a lot of bugs and you've responded to them? What's going on?
Oh yeah, people are pumped. I mean, one thing that we find in the community whenever we come out with a new language feature is there's always the process of, training and education and awareness. And I think the way that this feature was designed where, you really are just kind of decorating your existing synchronous methods and turning them asynchronous so easily is just a wonderful thing. And so the community is definitely embracing it.
Cool.
We had also seen, leading up to implementing this feature, we had seen the industry trends, and we had also seen a ton of customer feedback about this really being the hardest problem that people were dealing with in their applications. So we have our MVP program, MVP Summit folks came in and had to vote where should we focus, and this was high on the list.
Awesome.
And it's consistent with what we've seen across the blogs and other types of feedback.
And it's paid off because, of course, WinRT is totally asynchronous. This is a very beautiful and simple model. Developers need to still think about what it means to be asynchronous. Thank you for coming on Channel 9 Live.
Yeah,
and great work, you guys.